来，我们看的都什么东西啊？
占坑，翻译成中文就是占坑。
占中文。来，我们看的都什么东西啊
？Compilation. Compilation.
你们看得到什么东西啊？不知道这个麦还行不行啊？
你用电脑麦就可以。
哎，我怎么把它缩小啊？
那个好像要在外面调。
是吗？
好像可以直接。哎呀，不行哦。好像在。哎，我记得怎么调来着？你要干嘛？
我想开浏览器，我看一下。你们看到的是什么东西而已？
看到了。
是吗？哦，是一条拎出去了。
很正常 ，OK， 可以接受。
可以是吧？可以是吗 ？Hello。很正常是吧 ？OK。有人吗？人齐了吗？哦 ，I hear myself。OK。
因为我是看到这个屏幕。
是的。不要。
我们看到的是一个这个。
在这里。那个是岩石。对。多少个人？人齐了，我的资料又打不开。
是我看了几个人。我只看了2个人在说话。3个人。
Hello， 军哥。
嗨。
好累。
没关系，我是有妹子。
Hello, anybody here?
Yes.
Can you say hi?
Yeah.
In the chat room?
Hey, hi.
Today I want to say something about Angular compiler. In Angular 2, as we know that every Angular application requires a compiler process before they can run in the browser. The intrinsic components and the templates provided by Angular cannot be understood by the browser directly. During the compilation, Angular compilers also improve the app runtime performance by tracking JavaScript virtual machines features and include acceleration. Now let's go into this session. What we're talking about today. We will talk about why we need compilation in Angular, and what needs to be compiled, how it gets compiled, and when the compilation takes place. There is two ways of them, just in time or ahead of time. And what we get from ahead of time. And how ahead of time comparison works, and the backlogs of the AOT or JIT. Now, first let's talk about how comparison compiles our code. And to compile, when we write script, we need to write a template. And the template string will through the compiler, and the compiler includes three parts or more: parsers, lectures, or tokenizers. So after compilation, they will compile to the row level like machine language or machine commands in the VN code. So we can learn the application. Now, what's the compiler? Compiler will compile the hard code with written, and then through the computer, just like the compiler. It will take a set of programming of specification and translate them, and the output the lower level object code. So this is the normal compiler. So the compiler will include 4 major steps. It will scan our template string or our code, high-level code, and the rest of code analyze and the syntax analyze. The scanner will read 1 character at a time from the source code and keep tracking of which character is present in which line. And let's go analyze. The compiler will convert the sequences of the characters that appeared in the short code into a series of strings of characters. We note that as tokens, which are associated by a special route by a program called a resource analyzer. A symbol table is used by the resource analyzer to start the work in the stock code that correspond to the token generated. Sorry. I'm sorry, waiting for me. 我要把 Docker 关掉。
你把别的都关掉了，什么都关掉了。不要拿到。
Okay, let's continue.
也可以啊。有卡住吗？
没有。什么鬼？ Now let's continue. And the site test analyze. In this step, the site test analysis is performed, and which invoked processing to determine whether the token created during let's say analyzed are in proper orders as per their usage, and the correct order of the set of keywords which can yield a desired result, and is called the site test. The compiler has to check the short codes to ensure the site test accuracy. And semantic analysis. This set is compiled of several intermediate steps. First, the structure of the tokens is checked along with their orders with respect to grammar in a given language. The meaning of the token structure is interpreted by the pressure and the analyzer to finally generate an intermediate code. They called object code. And the object code includes instructions that represent the processor action for the corresponding token when encountered in the program. And finally, the entry code is pressure and interpreted to check if any applications are possible. Once applications can be performed, the appropriate modified tokens are inserted in the object code to generate the final object code, which is saved in which is saved inside a field. So what do we need? We need comparison for uttering higher levels of efficiency of our Angular application. For performance improvements, emerged of brand-wide consumption. For Angular 1 version, since the virtual machine doesn't know the shapes of objects, which provide context for the dirty checking logic. Its inline cache get a lot of messages, which slow the execution down. For Angular 2 and over versions, instead of using the shape logic for performing the renderings and and change detection for each individual component. The framework generates a VM-friendly code at the runtime or the build time. And this allows the JavaScript virtual machine to perform property access, catching and execute the change and detection, rendering logic much faster. So, what needs to be compiled? In Angular 1, as we can see it in this pictures, and this is next of the lightweight Angular JavaScript implement. From this did first search of the entry score tree, it will looking for changes in our bindings. And this approach will work for any directed. However, it is a bit rate slow compared to code which is directed specific. In Angular 2, it will generate the detergent change internal methods of compliant components. It gets the values of the individual bindings using deleted property access and compare them with the new values using the most efficient ways. Once it finds that their values are different, it updates only the Implus element. And when the compilation takes place, there are two ways: just in time and a hand of time. The cool thing of the Angular compiler can be involved neither running time or the build time. And this due to the portability property of Angular. We can run the framework on any platform with JavaScript virtual machine. So why not to make the Angular compiler run both in browser and Node.js? What is just-in-time? Just-in-time comparison, also known as dynamic translation, is comparison done during the execution of the program, called runtime. The just-in-time component will work like this. We write the component, and the just-in-time comparison will generate our code, and then the code will run in the VM virtual machine. So the build period just the component. At the runtime in the browser, almost does all the things. So this will slow down our performance and browser. So the just-in-time drawbacks, its bundle size will be larger, bigger, and because we need to measure the whole compiler's library load by the browser and the performance, and we also need to take longer to render because of the in-browser comparisons that the bootstrapping, the bigger apps take longer to transmit and are slower to load. Security comparison can uncover any component template binding errors. Just-in-time comparison discovered them at runtime, which is late in the process because they use the errors. What's a hand of time? Hand of time comparison is the act of the comparison high-level programming language into native machine code with the intentions of executing the result binary field metric. Hand of time process machine optimized code. The hand of time comparison will work like this. We write the component and here's the node. This is not JIT, it's AOT comparison. As we can see, most types occupy the build period, and the browser side just need the VN code to run the application. So the hand of time comparison in depth. Let's get the demo into how hand of time comparison work. What activates the new comparison process? What the context of the produced artifacts is? How to develop both hand of time friendly and well encapsulate code. As we can see, this is something of the component controller factory, and factory contains two definitions. There's a host component and a component, and there's two factory functions need to be implemented. In this slide, the component is the name of the component controllers, and the counter is an unsigned integer number. And the factory function both are only responsible for the instantiations of the generated apt views. The detach change internal contains the virtual machine factory code. So now let's take a look into the small template. Let's suppose the current value says has the value 3, and the expected says has the values 1. And now let's try the method execution. And the import checking binding will return the false. So we are going to start the change and update the model values of the engine model directed instance. Right after that, the detached components children changes will be invoked, which will invoke the detached change interval method for all the content children. Once the engine model detects finds out that there is something changed, it will update the related elements according to the context name. And it will update the corresponding element by directly calling the renderer. So the hand of type comparisons need the context. In Angular 2, the context will be the engine model maybe you will notice that within the internal component, we are setting the property to this context. The context of the internal component is the instance of the component controllers itself. This context will equal to the new hierarchy component. This means that in the detection change internal, we have to access the context name. here comes problem. And if we want to emit TypeScript as output of the hands-of-type compilation process, we must make sure that we access only proper fields in template of our component. Why is that? As we already mentioned, in the compiler can generate both TypeScript and JavaScript. Since the TypeScript has access modifier, and in Fox it access only to the properties outside the inheritance chain. Inside the internal component, and we cannot access any private properties part of the context object. So both hero and all the hero class named property private will cause and through the compiler time errors in the generate factory test field. In the first example, in the internal component cannot access heroes since the private is private within the component hero component. So we will bind only to properties and invoke only property methods inside the templates. But what happens with the component encapsulation? And this may doesn't seem like a big problem at first, but image the following sensory. The component has a single input name, and inside the named setters, we calculate the values like this slide. And we can use the component as follows. Like this, and since they're in just entitled model, the Angular compiler to generate JavaScript, and it works perfect. Each time the values of the named expressions change and equals to true value. So the init property will be recompute. However, the implement of the third-party component is not a hands-of-type friendly. To make sure that your sets only property and existing field in template, you can use the correlator. If we want to do so we have to change it like this. Which will leave the third-party component in an inconsistent state, and the values of the named property of the third-part component instance will be FB, but the values of the init will be MD. The answer of how to through these issues is wrote in the Angular code. And in case we want to make our code ahead of time friendly, like by only to properly propagate on methods in our templates. In the shape, time, and kit captures, we need to use TypeScript annotations internal to mark the initial values. The initial property will be public, but if we compile our third-party library with the TypeScript compiler and the striped internal and the declaration flag set, the initial property will be omit from the typed declaration fields for the third-party component. And this way, we will be able to access it within a boundary of our library, but it won't be accessible by its consumers. So let's have a quick recap of our session about the hands of time compilation. Now you can find the entries example summarization on this diagram. Now, let's talk about what we get from the hand of time. As we can see, this performance of the disk to compilation style. The hand of time gives up the tree shaping, and it will have the shorter time than and faster to iteration. There's no more dynamic code and less security issues and no more errors. That's conclusion this session. In the hand of time to improve the performance of our application because take the advantage of the inline catching mechanics of the JavaScript virtual machine. And forbid errors and less and more efficient chip shaking, improved the initial rendering time. Its disadvantage is generate the template of the components on diamonds also need to include the host compilers of an Angular module. And the final point is, according to the medium or large size application, in the instant they build bundle size larger than the just-in-time comparison. So today, my session ends here. Thanks for your time. Oh, yes.